So today we are looking at examples of how we can solve for the missing sides and angles of what we call oblique triangles. So you can see it there at the top. An oblique triangle is any triangle that does not have a 90-degree angle. So it could be an obtuse triangle, it could be an acute triangle like the one that we see in front of us, but there's just no 90-degree angle in there. But we can still use trigonometry to help solve. We can still use sine, and in a later lesson we'll see how we can still use cosine to help us. And it's in the form of two laws. So there's the law of cosines, which we'll look at later, and then there's the law of sines, which we're looking at today. And so the law of sines is just a simple proportion, essentially. If we take a look at the law of sines here, we see that the sine of angle A over the side across from A. So we need to make sure that we take note of our naming convention here. So angle A is the capital A, and then length A is the side across from angle A. So sine of angle A over length A is equal to the sine of angle B over length B, which is equal to the sine of angle C over length C. So essentially we'll just take any two of those, set them equal to each other, and then solve. But we have to be given the information in a couple specific formats for us to be able to use the law of sines. So we either have to be given angle, side, meaning two angles, and then a side that is not in between those two. That's what we see in this first example here. So you can see that we know two angles. We know the 80-degree angle and we know the 40-degree angle, and then we know a side length, that this 12 right here, that is not in between those angles. So that's what we call angle, side. We could be given the information in angle, side, angle formats. That's where we know the two angles and we know the side that's in between them. Or there's a third case, the side angle circumstance, where we know two sides and an angle that's not in between them. And we call it the SSA, not the ASS rule, because there's no bad words in math. But we'll look at that example in due time because there's a level of ambiguity, a lack of clarity in that example compared to the other two. So we'll spend time on this other one first. So in the case here, we're given the information in this angle, side format. Well, if we know that two of the angles of a triangle, then we automatically know the third side. We know that all the angles of a triangle have to add up to 180 degrees. So if we have 80 plus 40, that's 120. So that means we have another 60 degrees left to get us up to 180 degrees. So we know that angle A is equal to 60 degrees. So that leaves us just with two sides that we need to solve for. We have to figure out what lengths A and C are. So the foundation of our law of sines proportion is going to be the pair of angle and side where we know both of them, where we know both the angle and the side across from it. And in this case, that's true for angle B and side B. So we can write sine of 80 degrees, so sine of angle B, sine of 80 degrees over the side across from it, which is 12, is going to be equal to, and now we can use solve for either of the two sides, but we'll go alphabetical order, so we'll solve for A first. So that means it's going to be equal to the sine of 60 degrees over length A. And so what you can see here is we only have one variable in this proportion that we've written for ourselves. And I'm not going to worry about the angle C and side C. We'll solve for that in a separate proportion that we'll set up in a moment. But we can go ahead and use our calculator at this point, where we can push buttons so we can figure out what the sine of 80 is, divide that by 12. So we end up with A times whatever the sine of 80 turns out to equal. And then on the other side, if we cross multiply, we've got 12 times the sine of 60 degrees. And so then if we divide both sides by whatever the sine of 80 is, I won't bore you with the details there. You can push buttons on your calculator and figure this out. And hopefully you'll end up with 10.6 as the length of side A. And now we can go ahead and solve for side C in very much the same way. So we can say, again, start with that side angle pairing that we know. So we can go back to angle B and side B. So sine of 80 degrees over 12 equals the sine of this time 40 degrees, that's angle C, over length C. So we can once again cross multiply to solve our proportion. So we've got C times the sine of 80 is equal to 12 times the sine of 40. So this is just calculator work at this point. We do 12 times the sine of 40 degrees. We divide that by whatever the sine of 80 degrees is. And so we eventually end up with C equal to 7.8. And one way that we can kind of double check to make sure that those answers make sense for this example, we know that the larger the angle in a triangle, the longer the side across from it. So angle B should have the longest side, and indeed it does. 12 is the longest side. And likewise, angle C is the smallest angle in the triangle, so it should have the shortest side, and we can see that that turns out to be 7.8 with length A is 10.6 in the middle. So we feel pretty confident that we've got that problem.